Hello everyone, I am going to talk about GPU, Graphics Processing Unit. What is Graphics Processing Unit? Graphics Processing Unit is a specialized processor designed to rapidly handle parallel computation. Originally built to accelerate rendering of images and videos, GPUs now powerful AI, scientific stimulation data processing. In high-end GPU, 16,000 Ci CAD core will be present. Memory byte background bandwidth will be HH for 1.5 TB, more cores than typical CPU. CPU has 4 cores to used to stimulate process. GPU has thousands of small cores used to do multitasking at the same time. GPU architecture, streaming microprocessor, group of CAD core that shares resource. Each streaming multiprocessor handle thousands of threads simultaneously. CAD core and shared processor. Basic computation units executes floating point and integer operation in parallel. RAP scheduler schedules group of 32 threads for execution, handling memory latency through context switching. Register file and shared memory. Ultra fast on chip memory shared with streaming microprocessor, critical for Intel thread communication. L1, L2 cache plus VRAM. VRAM holds the textures, frames, frame buffer, model weight. HBM2 provides 1 TB of bandwidth. Memory hierarchy. GPU has register, shared memory, L1 and L2 cache, VRAM in HBM largest. Parallel processing and SIMD. SIMD. Single instruction, multiple data. Add instruction and fetch instruction, all 4 completed in parallel. Multitasking is explained in this process. GPU thread hierarchy. Grid. Entity GPU kernel launch. Thread block. Group of thousands sharing memories. RAP. 32 threads executed in lock steps on the one streaming multiprocessor. Thread. Individual execution unit. 32 threads are wrapped. 1024 max threads are per block. 65,532 max block per grid. 10 power 9 threads in a single latch. GPU versus CPU depth drive. Fetch CPU. Features. CPU core is 4 to 64 cores. GPU thousands up to 16,896. Clock speed 3 to 5 GHz. GPU 1.5 to 2.5 GHz. Thread model. Few heavy threads, millions of lightweight threads. Memory. Large RAM, DDR RAM, VRAM, HBM RAM, ultra high bandwidth. Best AT. Sequential complex logic. Parallel representative operation. Latency. Optimized for low latency. Tolerance latency by thread switching. Use case. OS app database. Gaming, AI, simulation, rendering. GPU memory architecture. Global memory. VRAM. Speed low to medium. Size 8 to 80 GB. Large pool. Accessible by all threads. Main workhouse for data storage. Shared memory. Speed very high. Size up to 100 kbs. Shared streaming multiprocessing. On-chip memory per streaming multiprocessing. Used for inter-thread collaboration within a block. Register. Speed faster. Size 65K per shared multiprocessing. Private to each thread. Zero latency. Limited spelling on global memory is closer. Custom memory. Speed high. Size 64 KB. Read only data. Broadcast to all threads simultaneously. Ideal of weight frames. Texture memory. Speed high. Size varies. Optimized to 2D spectacle. Special access version used in rendering and image processing. L2 cache. Size high. Size up to 50 MB. Shared cache access all SM. Reduce global memory access significantly. GPU processing programming model. CAD, NVIDIA most widely used GPU programming platform. C++, C++ exploration let developers write kernel functions that run on a GPU. Powers most of modern AI ML machine language. OpenCL, cross-platform framework for CPU, GPU, FPGA programming. Vendor agency work on AMD, Intel, NVIDIA widely used in scientific computing. Metal. Apple is lowest level GPU API of iOS, Mac OS. Tight integration with Apple's Silicon Unified Memory Architecture, CPU plus GPU shared memory RAM. GPU applications, gaming and real-time graphics. Rasterization, ray tracking, shared texture mapping, modern GPU render 4K at 120 plus FPS with photoelastic lighting, AI and deep learning. Training natural network matrix multiply is massively parallelizable. GPU are 10 to 100 into faster than CPU of DNN training. Scientific stimulation. Molecular diamond scientific simulation, molecular dimensic weather forecasting, for flooding stimulation, physics engineering, all benefits for massive floating point throughputs. Image and video processing, real-time encoding, decoding, AI upscaling, computer vision, and medical imaging, cloud and data center. Azure GPC, all of offer GPC instructions, hyperscaling, use GPU clustering for LLM, influencing, rendering, frames, and analytic. Evolutions of GPU. NVIDIA GeForce, first GPU hardware T and L fixed pipeline. NVIDIA G80 CUD, unified shared model GPU computing bond. Fermi architecture, ECC memory, Pascal, first HBM2 GPU, NVLink 16nm fine FET, Ampere, 80 GB HBM2E, TF32, Hopper, Transform Engine, 4th Gen, Tensor Core, Blackwell, 20 petal flops, NVLink 5.0, AI superscript. Key takeaways. Massively parallel GPUs excel at running thousands of lightweight threads simultaneously, ideal of data parallel workload like Matrix Max and rendering. AI backbone. Modern AI ML is graphics dependent, training LLM, CNNs, and diffusion model would take years on CPU, GPU, and do not do it in day or hours. Architecture matrix. SM, RAMs, shared memory, and HBM work together in hierarchy. Understanding this unlock platform optimization beyond graphics. Today, GPU are generally purpose accelerators used in geomic, finance, climate modeling, and more. Thank you.